Hi, and thanks for joining us in this next of a series of sessions on the 2D frame analysis module in the Structural Engineering Library. The subject of this video is establishing steel design parameters. And just for some background, in case you're just joining us, we have a model that has been fully constructed representing a single bay braced frame of steel members. The model has been properly constructed. Materials and sections have been assigned, loads have been defined and assigned, load combinations have been created, the model has been run, and we've actually validated our analysis results by taking a look at deflected shapes, and we've seen how we can go in and take a look at shears, axials, moments, and deflection values in previous video sessions. We're now up to the point where we'd like to prepare this model for a proper steel code checking session. And so what we'll do is move to the Members and Loads tab and then the Member Data sub-tab. Now previously we skipped over the sections that were used to define the unbraced length, the slenderness, and the values of CM and CB for steel members. But now what we'll do is we'll talk about these sections and see how we can use those to control our design. Now the first thing that we'll do is talk about unbraced length. And the unbraced length in the 2D frame analysis module serves double duty. The values that are defined for unbraced length about the z-axis and about the y-axis are used both for flexural capacity determination as well as for axial capacity determination when multiplied by the corresponding K factors to determine an effective length. By default, the members come in with values of unbraced length set to a -1. The -1 indicates that the full length of the analytical member will be considered to be the unbraced length. So if that's our design intent, then we don't have to do anything with those values. We can just leave them at their full unbraced lengths. Now let's just assume that that is what we want to do in this model for the columns and for the braces, but perhaps we'd like to do something different with the beam. So what we could do is we could find the beam, which is member B. And what we could do is say that for buckling about the Z, the strong axis, the axis that is perpendicular to the plane of the frame because our member is oriented in the strong direction, we might say that for that direction, the member is to be considered as unbraced for its full length. So for strong axis buckling, the member would be considered to be unbraced for its full 28-foot length if we left the value of -1. For buckling about its weak axis, though, what we might choose to do is come in and say that we have, perhaps it's wood joists that run across the top of these members, and we consider them to be bracing at 2'4". So we can actually key in a value, and just remember this will set the value of the unbraced length both for the flexural analysis as well as it will be multiplied by the corresponding K factor for the unbraced length for axial capacity as well. What we might do in this case is just restore that to a -1 so that we can see how that would work. And then we can move over to the K factors. Now, again, we can use nomographs to determine K factors or some other sort of analysis. I'll leave them all set to values of 1, but they can be edited as you see fit. As far as the values of CM are concerned, what we might do in this case is assume that the value of CM for the beam will be 1, and for the braces it'll also be 1, but perhaps we would come into the two columns, which are members A and C, and establish values of 0.6. Now this is just an example to illustrate how you can set these parameters and how they'll be incorporated into the steel design. Now for the values of CB, what I'll do in this case is just assume that I want to use a value for the beam of 1.56. I've just calculated that off to the side using the formula from AISC. And I'll just leave the values set to 1 for the columns and for the braces. But again, this is user preference. You can choose to enter these values any way that you see fit. So I hope that that gives a good background as to how you can set these design values, design parameters for steel design in the 2D frame analysis. The next step that we'll take a look at in the following video will be actually performing the steel code checks and reviewing the design results. Thank you very much and have a great day.